Today, we cover integer exponents. Recall that an integer is a whole number, like -2, -1, 0, 1, 2, etc. Those are integers. This is the notation for an exponent. It reads a to the mth power. A is the base, m is the exponent. Today, we'll assume that m is an integer. Then the definition of an exponent is that we multiply MAs by each other. For example, a to the 2 equals a times a to the 4th equals a times a times a times a to the 7th equals a times a times a times a times a 7 times. That's what an exponent means. We'll learn the 5 rules of exponents. The product rule, which says that a to the m times a to the n equals a to the m plus n. The quotient rule, which says a to the m divided by a to the n is a to the m minus n. The zero exponent rule, which says that a to the 0 is 1 no matter what a is. The negative exponent rule says a to the negative m equals 1 divided by a to the m. And the power rule, which states a to the m to the nth power is a to the m times n. I'm on page 61. First, we have the product rule, which says that a to the m times a to the n equals a to the m plus n. This example here shows you how that works. 2 to the third means 2 times 2 times 2, and 2 squared is 2 times 2. If you multiply these things together, the result is that you're multiplying 5 2's together. 2 times 2 times 2 times 2 times 2 equals 2 to the 5th. Part C, 2 cubed is 8, 2 squared is 4, 8 times 4 is 32, and we can check on a calculator that 2 to the 5th is 32 as well. So these two agree. Now we'll test this rule. 3 to the 4th is 81, 81. And 3 squared is 9. 81 times 9 is 729. 3 to the 4th times 3 squared should be 3 to the 6th by our rule. And if we look on the calculator, 3 to the 6th power is 729. The quotient rule says that when you divide two exponents with the same base, you subtract the exponents. It would be a to the m divided by a to the n equals a to the m minus n. 2 to the 5th is 2 times 2 times 2 times 2 times 2. 2 to the 3rd is 2 times 2 times 2. We can cancel 3 of these 2's, and that leaves us with 2 times 2, which is 2 squared. So part B will be 2 times 2 equals 2 squared. Now we'll confirm that these two expressions are equivalent. Recall that 2 to the 5th is 32, 2 to the 3rd is 8, so 2 to the 5th divided by 2 to the 3rd would be 32 divided by 8, which is 4. And using the quotient rule, we got 2 squared, and that's also 4. And the general rule will be a to the m divided by a to the n equals a to the m minus n. For part E, let's try an example. 5 to the 6th equals 15,625. And 5 cubed, I happen to know off the top of my head, is 125. 5 to the 6th divided by 5 cubed by the quotient rule would be 5 to the 6th minus 3 is 5 cubed, and that would be 125. So checking it on the calculator, 5 to the 6th divided by 5 cubed equals 125, which is 5 cubed. Next, we have the zero exponent rule, and this says that anything to the power 0 equals 1. Using the definition here, we have 5 fours on the top. We have 4 times 4 times 4 times 4 times 4 divided by 4 times 4 times 4 times 4 times 4. And each of these is going to cancel out, and we'll be left with 1. A number divided by itself is always 1. Part B. Using the quotient rule, rewrite the expression. Remember that the quotient rule is what we covered in the last part. It said that a to the m divided by a to the n equals a to the m minus n. So we're going to have 4 to the 5 minus 5, and that's 4 to the 0. Equating these, we have 4 to the 0 equals 1. So our general rule is that a to the 0 equals 1. Note that even 0 to the 0 power equals 1. If we look on a calculator, 0 to the 0 power is 1. The story is actually more complicated. Sometimes it's indeterminate, but for most applications, you would treat 0 to the 0 as 1. But yeah, in any other case, the number to the 0 power is going to be 1, and that actually follows from the quotient rule. So like 600 to the 0 power is 1. Anything to the 0 power will be 1. Now the negative exponent rule. We have 3 to the cube divided by 3 to the 6th. If we break this up using the definition of an exponent, we'll have 3 times 3 times 3 divided by 3 times 3 times 3 times 3 times 3 times 3. 3 of these will cancel, and I'm left with 1 divided by 3 times 3 times 3, which is the same as 1 over 3 cubed. And that's would be the answer to B. Using the quotient rule, we get 3 to the third minus the sixth, and that's the same as 3 to the negative 3. We equate these. 1 over 3 to the third equals 3 to the negative 3. The general rule is that a to the negative m equals 1 divided by a to the m. Making the exponent negative gives you the reciprocal of the original. Like a to the negative 1 is 1 over a. So 2 to the negative 1 would be 1/2. 3 to the negative 1 would be 1/3, etc. What is 5 to the negative 2? Well, our rule says that that's going to be 1 divided by 5 squared, which is the same as 1 over 25. And if we check the calculator, 5 to the negative 2 is 0.04. 1 divided by 25 is also 0.04.